Today we're going to be focusing on the distributive property. This is just another way of evaluating expressions. So the distributive property basically states if you have a number A and you're multiplying that times B plus C, that is going to equal A times B, because that's where you get your A times B. Then you're adding A times C. So then you have your A times C. So you have A times B plus A times C. And this is what it looks like algebraically. If you look at it with numbers, let's just use the example 3 times 2 plus 5. We know if we use order of operations, we would do the inside the parentheses first, where it would be 2 plus 5, which would be 7, and then 7 times 3, which would be 21, and that's fine. You get the same answer. But if I'm specifically asking for the distributive property, I want it to be written out as you go 3 times 2. And then you have your plus sign. Then 3 times 5. So this is what the distributive property is going to look like when it's written out. So from here, we do the 3 times 2, which is 6. 3 times 5, which is 15. Add those together, and that is where 21 comes from. We can even use the distributive property even when there are variables in the example. So in this one, let's say that we have 7 times 3x minus 5. So the very first thing that we're going to do, we are going to multiply this 7 by 3x. So we can multiply 7 and 3x. So what we would do, we would multiply the 7 times 3, which would be 21, and we also have to bring the x along with us. So the next thing that we do is we have our subtraction sign, bring it straight down, then we do 7 times 5, which is equal to 35. Now this right here is our final answer, 21x minus 35. We cannot combine these terms because this 21x, remember this x is a variable. This 35 is just a constant. It's just going to be 35. There is no x that goes along with it. If 21x is like puppies, 35 is like kitties, we do not combine these two. Puppies and kitties do not mix. So our final answer is going to be 21x minus 35. So now I want you to try this next one. If we have 8 times 2 plus 5y. Alright, pause the video, try to do this one, and push the play button when you're ready to see the way that I solved it. Alright, so we are going to move forward. So we take our 8 and we multiply the first term that we have, 8 times 2, which is 16. We bring the addition sign straight down. Next we multiply the 8 by the 5y. So with this we are multiplying 8 times 5, which is 40. And then we still have to bring along that y. So the final answer is 16 plus 40y. We cannot combine these because this 40y has a variable and the 16 does not. We cannot combine these two. So this is the final answer, 16 plus 40y. When we're combining like terms, it's basically like using the distributive property but in reverse. So for example, let's say that we have 17x plus 25x. We could just add them together to equal 42x, but I would like this in distributive property terms. So, if we remember, it is going to equal, so if we're combining these terms, we could do 17 plus 25x. Since x is the similar term in both of these terms, we could redistribute the 17 and the 25 and combine them together into one parentheses, since x is the common factor and they're going to be on the outside of the parentheses that we're going to multiply by. So what I want you to try now, I would like you to try to combine these terms. If we have 4m's and we're adding together 3m's, I would like to see what is this going to be equal to, but I would like to see the work using the distributive property. So pause the video, try this, and see and unpause the video when you're ready to see how I solved it. So it looks like the common factor within this are the m's, so we can combine the 4 and the 3. So we do 4 plus 3, and since m is the common factor with these, we can have m on the m side. So if we have 4m's and we're adding 3m's to it, we are going to have 7m's as our final answer. Alright, so now I want to have these two examples, and what I want to do is I want to simplify the expression. So let's look at the first one real quick. If we have 2x squared plus 3y squared plus 14. Now, you may think that you can add the 14 to either the 2 or the 3, but that's not the case. 14 does not have a variable that goes along with it. So 14 has to stay by itself. Same with this x and this y. Do you see how this is an x and this is a y? We cannot combine these like terms. This is actually x squared and this is y squared. We cannot combine these terms. So this right here, this is already simplified. Alright, let's look at our second one. We have x squared and 2x. You may think that since we have an x here and an x here, we can always combine them. But this is so important. This is x squared, and this is just x. If it's x squared and x, we cannot combine these. So this is also simplified. This is also simplified. You cannot combine these, basically because this one has an x squared to it and this is just an x.